Hey, welcome to Unit 3, Lesson 8 lessons. We are going to do some practice packet work, but I thought I'd make a video to go over some of the questions. So if you wanted to skip and check your work, I'm here for you. So let's go ahead and start. This is, the homework is pages 17 to 20 odd problems. So I'll go over some of those and then you can look in the bookmarks to see where you're at. So let's begin with the first ones. Which atoms, or which of the following ones have the smallest atomic radius? Well, looking at the periodic table, let me just move that over here. There we go. I know it's a small box. You may not be able to see perfectly, but you have one in front of you. The idea of the atomic radius decreases, that nuclear force decreases and pulls on those electrons with additional strength as you go across. So elements like chlorine that are very close to the edge of the noble gases have the smallest atomic radius. Right? And then when you compare it to something like sulfur, it's a little bit more to the right, so it's smaller than sulfur. When you compare it to phosphorus, it's more to the right. And if you compare it to what other ones, silicon, even further. So chlorine by far has the smallest radius based on the trend that it gets smaller going towards the right. All right. Let's try that again. There we go. Okay, the distance across an atom of an element in the solid phase is 256. This is picometers. The atomic radius of an atom in the element is closest to, all right, let's understand this. The atomic radius, what is the radius? So if we have an atom that is spherical, the radius is that distance from the center to the outside edge. That's the radius. And so if we have a diameter, it's just a question of what does it mean to be across. To be across is this distance. So it's exactly half of that. That's why it's 128. All right, a solid sample of element phosphorus can be white. Oh, you know what? I said I would do odd, so I'll focus on that. Solid samples of element phosphorus can be white, black, red in color. The variations of color are due to differences of light. All right, so just like we learned in the notes, we can have different versions of the same element. That's oxygen, and that's ozone. They have different chemical and physical properties we mentioned because they have different structures. And these are called molecules, and these are called different molecular structures. All right, let's move on. And of course, if you want a more thorough definition or explanation, just ask me a class. What occurs if the atomic number of the elements in period 2 increases? So, oh, I'm covering some of the questions. Move that over, sorry. I did want to use the periodic table for this one because as you move across the periodic table, you will notice that the nuclear charge of each successive atom increases. That's true because you're adding one more proton to the nucleus. And the atomic radius decreases. Yet with additional proton with the same shell, the proton with pulled in the shell closer and closer to itself. That's why the radius decreases. All right, number 7, the radius of calcium ion is smaller than the radius of the calcium atom because the calcium ion contains the same nuclear charge in what? Well, we have to understand the idea of what happens with calcium. You notice calcium is in group 2, and you see its oxidation is +2. It means it goes from calcium elemental to calcium ion, +2, and that must mean it lost 2 electrons. So if it lost 2 electrons, it means its whole outer shell, which normally has 4 levels to it, 1, 2, 3, 4, it loses its outer shell, and it becomes a lot smaller, and the thing we want to look at here is it has fewer electrons, because it lost its 2 electrons that would be on the outer shell. And let's move on. Number 9, the atomic number increases within group 15 on the periodic table. So we take a look at group 15. Remember, groups go up and down. So as we go from 7 to 15 to 33, it's asking for a atomic radius. What does the atomic radius do? Well, with each additional shell, so for example, in group 15, nitrogen has 2 shells or 2 orbitals, but then phosphorus has 3 orbitals. By the way, it's period 3. So energy level 2, energy level 3. What I want you to understand is the pull that the protons have towards the nucleus is decreased with the shielding of orbitals. So what does that mean? It means that the atomic radius will start increasing as you go down because the nucleus has less and less power to pull on it because those multiple shells have a shielding effect. All right, that's the key language and understanding there. Which statement best compares the atomic radius of a potassium ion to of a calcium ion? All right, I better move this over here. So lemon, the potassium. Okay, so there's phosphorus, and is what we're comparing it to, or just potassium and calcium. Okay, let's move over here. So we have potassium, and calcium, and we're comparing the 2 atomic radii. Well, first of all, we know that calcium has 1 more proton than potassium, so we can just see that the radius of the potassium ion would be larger because the calcium ion will have 1 more proton pulling it in, so it has a higher charge for that one. That's about it. Same concept as before, the nuclear force pulling it in. All right, let's move on to the next page. And look for bookmarks again if you want to skip to a certain page. 13. Which element of group 2 on the periodic table is arranged in order of increasing atomic radius? So we take a look at each of these, and we take a look at our periodic table. And let's take a look at the first one. We have barium, radium, and strontium. There's barium, radium, and strontium, and you'll notice they sort of hop around. That is definitely not true. And I do like the idea of barium and radium, but then strontium is completely out of order, so it is not that one. So we'd expect them to either increase going down or decrease. But even if you didn't know that, you know it couldn't possibly be this one because it doesn't follow a pattern. But let's try to understand it chemically what's happening. Remember, as we go down a group, that power, oh, my bad, I should have drawn it the other way. As we move down a group, there's less and less shielding. Or, boy, less and less radiation. Oh, boy, this is, I apologize. The nucleus has less power to pull those outer electrons because there's more and more shielding. So over here, there's just maybe no shell, so that proton in the nucleus pulls it in tight. Over here, there's 1 shell, so it doesn't pull as tight, and it's a little bit larger. And over here, even though the ratio to the protons to electrons is the same, the shielding, the number of orbitals that are in its way, prevents it from pulling in. So I followed that in one note with the wording, but the beryllium, magnesium, calcium sequence right there is the one you want to look for because it shows that there's increasing atomic radius as you go down a group. Okay? You can simply use your notes, but also I want to give the explanation. Okay, number 15, which element is arranged in order of increasing atomic radii? Same idea. Let's just take a look at which ones we're given. We've got scandium, titanium, vanadium, and chromium. So this is a great time to just get used to the periodic table. There's this thing, and what it's really asking is, do you know which way the periodic table gets larger or smaller? All right, that's what it's really asking. And so the general rule, remember, is as you move down a group, as you move down a period, you start with elements that have a larger radius, and they get smaller as you go down because the number of protons is increasing by one, the number of electrons is increasing by one, but the number of shells stays exactly the same. So the protons have an increased effect of pulling that and win the tug of war. As you add more protons, the electrons are just equally distant, and so they pull even deeper. So with 15, fluorine, chlorine, bromine, and iodine is a connection for going from increasing atomic radii, okay? Because they go from smaller and bigger and bigger and bigger. Why do I say that? Because, I'll show you. Remember the shielding effects we just talked about? Who has the most shielding effects? Iodine, so it has the largest radius. Those electrons are pulled the weakest by iodine. All right, let's move on. Which ion has the largest radius? All right. Boy, I feel like I'm being repetitive with these, but the largest radius, again, we'll take a look at it and try to do an explanation for you, but what we're looking at is either calcium or potassium, sodium or magnesium. So we have two pairs. Well, first of all, it can't be these because calcium and potassium are larger. And we know that atomic radii gets bigger as you go down. Okay? So if that's the trend, then I think you know it has to be from period 4. But then you have to ask yourself, which of these two will it be? And for that one, we know that they get, smaller as you go from left to right. Okay, so the answer would be potassium, because you'll see potassium is over here, and the calcium is a little bit smaller, and so forth all the way down, because of that winning out of the nuclear charge. Okay, magnesium atom differs from the magnesium ion in that the atom has a what? Well, definitely has a larger radius. All right, because it has more electrons in its outer shell. All right, 21. Whoop, wrong thing. Let me move this. Which of the following particles has the smallest radius? So the first thing you want to think is we're going to probably think the ions that have lost an electron have the smallest radius. And so you want to zero in on those. And then we just take a look at the periodic table and say to ourselves, well, there's sodium, and I'm comparing it to potassium. And if you recall, if these all things are given equal, and then the sorry, I lost my train of thought. 21. Okay, and then the sodium will be the smallest one, the smaller one. Oh, sorry. Here I am. There we go. And why is that trend? Because it goes from small to bigger. With every level period you go up, the more shielding occurs. So the smallest atoms are towards the top. Okay, let's move on to 23. Which grouping of circles, when considered ordered of the top and bottom, best represent the size of the atoms of lithium, sodium, potassium, and rubidium? So again, find those on our periodic table in group 1, and we want the order to be lithium, sodium, and so lithium should be, remember we're going from small to bigger, so lithium should be on the smallest, and then sodium, and then potassium. So we should have an ever increasing one, so it's looking like I think I see the one, and rubidium should be the largest. All follows that same pattern I think I've been drawing, that with increasing shielding effects down a group, the atoms get larger. So hopefully that makes sense. And let's move on to 25. Which of the following electron configurations represent an element with the smallest atomic radius? All right, perfect. Okay, so the idea here is where's my drawing? Well, first of all, let's move this sucker out of the way. No, you still need to see that. Okay, sorry. You don't have to look at the elements to see this, I don't think, but you do have to recognize these are all moving from, these are represent different positions in the group. Group 4, Group 7, Group 5, and Group 6. And then what I'm going to ask you to do is remember how things move across the periodic table. They get smaller as you go across a period. Remember that? And they get smaller, but they get larger as they go down a group. So the smallest one will be the one the farthest along the largest group, and that's option C for that one. So that's 25, perfect. And then let's move down to 27, which of the following ions has the smallest radius? So they all look like ions. Remember the negative ones, guys, will have a fairly large when its atom because it's taken on electrons. So try to remember that. And then let's take a look at the periodic table. We have fluorine, element 9, 2 shells. So it's in period 2, now here. And the potassium is K, and it's period 4. So its energy level is 4. It has 4 shells. Calcium has 4 shells. And chlorine has 3 shells. The reason I'm doing this, guys, is because I want you to understand, even though fluorine gained an electron, and so technically it has a full, complete 2 shells, and takes on the look of a neon. It's isoelectric with neon. But what I want you to understand is it's not neon, it's fluorine, it's an additional electron. But it only has 2 shells. And that's what I want you to understand is why 2 shells is smaller than 3 shells or 4 shells. And that's all there is to that one. All right, and I think we're supposed to move on to page 20. So we're almost there, halfway done.
At this time, anyone?
Okay, compared to an atomic radius of a sodium atom, the atomic radius of a magnesium atom, the smaller radius is primarily a result of magnesium having what? All right, just take a look at the periodic table and see if we can make sense of this. We're comparing sodium and magnesium, and the comparison will lead to say, oh, the only thing magnesium has that's greater than sodium is 1 additional proton. And what that means is an additional proton means it has a larger nuclear charge. It's the same period, so not the energy level, same energy level, smaller, definitely not because it has 1 more proton. So that's how that one works. 31, an atom of which element has an ionic radius smaller than its atomic radius? That's a really good question. It is rubidium. And the reason is because the rest of these all go to negative ions. You can look in their oxidation states. You can find the oxidation state top right, and you'll notice that all of these elements, for example, nitrogen, let me just slide that over. Nitrogen carries most commonly a -3, a -2, -1 charges. And because of that, they've gained electrons, so their ionic radius is larger. Same with sulfur, same with bromine. And now rubidium is the only metal there. And rubidium, of course, is a group 1. And what did group 1 like to do? Give away electron, form a positive. So that's that. 33, which group in the periodic table contains elements of some ions which are larger than their atoms? Group 17, because those ions, you'll see again, like I just explained, have negative charges. Question 35, a chloride ion, which means Cl negative, from a chlorine atom, the chlorine ion has what? Well, it has 1 more electron, so that's true. A larger radius, true. More protons? Nope, that would make it a different element. Fewer protons? Nope, that would make it a different element. A smaller radius? No. If you gain electrons, let's see, the chloride ion, definitely larger radius because it gained an electron. An atom of which element has, oh, we have to do that one. Okay, let's move on to the last page. All right, the data table below shows elements X, Y, and Z with some special notations there. What is the most likely atomic radius of element Y1? Okay, well, let's see, atomic radius. Atomic mass units. So we know atomic Y has a jump of about 30, 40, and then a jump of about 90. And so if we know that this element is, oh, from the same group, by the way. This is important because we just want to recognize what happens in groups. If you recall, groups start off smaller, and then because of shielding effects, they get larger as you go down a group. So that's sort of important. And we'll look at our options. 185 means somehow, even though this element Y is in the middle of the group, it got larger. That can't be possible. 103, well, if the radius is 141 for the higher level group, it can't be this one. 166, that's right between those two, and that is correct. All right, can't be this one, okay, just following the first one. Okay, 39, an ion of which element has a larger radius than an atom of the same element? No good? Yeah, no good on the screen. An ion of which one has a larger radius? Okay. Larger radius means it must gain an electron. So we're basically looking here to see if any of these gain electrons. And metals all donate electrons. So magnesium you see on the periodic table is a metal. Sodium is definitely a metal. Right? We got sodium over here, and we got magnesium over right next to it. And then aluminum is a little trickier, but it is a metal right there, right next to the staircase. Not a metalloid, it's a metal. And so all of the metals have something in common. They all give electrons. And fluorine is the only one to gain electrons. It's group 17. And that, I believe, is that. So thanks for watching.